Okay, we need a line for each of the factors for 5 minus x, for x plus 3, for x plus 8, and for the quotient. So here I have a line for each of these. And at negative 8, this one is 0, so we need to start off at negative 8. Then at negative 3, we have another one. And at 5, that's where the 3 zeros are. Don't need to worry about. 5 minus x is 0 and x equals 5. And if x is bigger than 5, like 6, 5 minus 6 is negative. So it's negative to the right and positive to the left. Remember, there's a negative in front of the x term. It's switched. Usually it's pluses to the right and negatives to the left. Like on this one, x plus 3 is 0 and x equals negative 3. And it's positive if x is bigger than negative 3 and negative if x is less than negative 3. X plus 8 is equal to 0 and x equals negative 8. And it's positive if x is bigger than 8, negative 8, and negative if x is less than negative 8. Now, this x plus 8 factor comes from the denominator. So when that's 0, our expression is undefined. But here we have a positive, negative, negative, that makes a positive. A positive, negative, positive makes a negative. 0 in the numerator makes the whole thing 0. A positive, positive, positive makes a positive. 0 in the numerator makes the whole thing 0. And a negative, positive, positive makes a negative. So that line tells us everything about the quotient. So we can graph it from that. The graph of the solution set then. Make a point at negative 8, negative 3, and 5. And a circle around each. We're wondering here, where is this quotient less than 0, which is negative or 0? Negative or 0. The negatives and the zeros. The zeros occur at negative 3 and at positive 5, so let's fill in those points are included as part of the solution. And this point. And other than that, the negatives are to the right of 5 here. So everything to the right of that 5 gets shaded. So that's part of the solution set to the right of 5 and including 5. And between negative 8 and negative 3, it's negative in there as well. So there's some additional points in here, part of the solution set. So there we have the graph of the solution set. And in interval notation, well, this is negative infinity and infinity at the end of the line on the right. So in interval notation, this is the interval from negative 8 up to negative 3, including the negative 3, but not including negative 8, union the interval from 5, including 5, to infinity. Finally, in set builder notation, this is the set of all x, such that x is in between negative 8 and negative 3, or x is bigger than or equal to 5. So there are 3 ways here of expressing the solution set to this rational inequality.